Hello students, already we have discussed about the addition of two vectors. Now we'll discuss in this video analytical method of vector addition, that is in two parts we'll discuss the triangle law and the parallelogram law. Now see what is the triangle law of the vector addition of the two vectors. Suppose these are the two vectors, vector A and vector B. Okay, now add these two vectors by triangle method as already discussed in the previous video. Okay, vector A, and then from this head add the second vector, vector B, and now join the initial and the final point, that is the from here to here, and it represents the resultant vector. Okay, now see what is the law. It states that if two vectors are represented in the magnitude and direction by the two sides of a triangle taken in the same order, this, okay, then their resultant is represented by the third side of the triangle in opposite order. Okay, not 1, 2, not this, it is just in opposite order. Okay, so R represents the resultant of these two vectors, vector A and vector B. Now we'll find a formula. See, if you see this triangle using the Pythagoras, you can see here OQ square is equal to OE square plus QE square. Okay, it is the perpendicular, so it is equal to OE square plus EQ square. Now here you can see OE is equal to, since OE is equal to OP plus PE. Okay, OP plus PE is equal to OE. So right here, so OP plus PE square plus EQ square, open the bracket, OP square plus PE square plus 2 OP PE plus EQ square. Clear? Now if we take PE and QE, so it is another triangle and it will be equal to the PQ. So PE, this one, and the EQ, so combine both, so we can write OP square plus PE square plus EQ square plus 2 OP plus OP into PE. Okay, and this equal to PE plus EQ is equal to PQ square. So here we can write OP square is equal to E plus PQ square plus 2 OP PE. Is it clear? Now see what is the OQ square. OK, it is the resultant square, so here we can write R square, it is equal to R square, and OP, it is the A square, PQ, it is the B square plus B square. Okay, OP is equal to A and PE is equal to this is the angle, so it will become PE. What will be the PE? PE is equal to base, it is the base, so we can write it is the B cos theta. Okay, we can write it is the PE is equal to PQ, or you can understand like this, PE is equal to PQ cos theta, that is the cos of the hypotenuse. So simply can write PE is equal to, using this angle it is the base, so it is the B cos theta. Here write the PE is equal to B cos theta. So dear students, this is a formula, desired expression, that is the R is equal to under root A square plus B square plus 2AB cos theta. where theta is the angle between the first vector and the second vector. Angle between the vector A, this is the direction of vector A, and this is the direction of vector B. So this is the angle between the two directions. So theta is the angle between two directions. So resultant depends not only on the magnitudes of the individual vectors A and B, it also depends on the angle between them. Now we can find this resultant angle also. Suppose alpha is the resultant angle of these two vectors, because it is the angle between the first vector and the resultant R. So we can write here the tan alpha to find the angle alpha. Tan alpha is equal to, that is the base perpendicular upon base. Tan means, so perpendicular is here QE, and the base is here OE. So QE means this is the cos theta, and it is the B sin theta. QE is the B sin theta. So here we can write B sin theta, and QE means A plus, this is the A, and PE means, again we had discussed, it is the B cos theta. So this is the angle, resultant angle of the two vectors. Okay, so this is the analytical method of vector addition, and it is the triangle law of the vector addition. Now the same formula you will find if we follow the parallelogram law of vector addition. It was the triangle law. Now come to the second law, that is the parallelogram law of vector addition. Okay, see what is the law. It states that if two vectors, just in the same, if two vectors represented in magnitude and direction, very easy to remember, by two adjacent sides of a parallelogram drawn from a point, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn. Okay, so this is the parallelogram, and the resultant, in the same way you can see here, I'm making the diagram. You can see there is no difference. Suppose this is a vector A. Okay, vector A, this is the vector B. Okay, it is the vector B, it was the vector A. Okay, and this is the angle between them. Theta was the angle, as we had discussed here in this formula. Okay, if we draw a parallel line, parallel here, okay, like this, and parallel here, okay. So these two vectors, if these are the two adjacent sides of a parallelogram, then the resultant is the diagonal. This is the diagonal, okay. This is the diagonal, say alpha. So what is the difference? Almost the same diagram, na? This A, B, and this is the angle theta. So we can find the same formula in the same way for the parallelogram law also. So no difference.